Okay, so today we're going to be doing our third regression activity. And what two kinds have we had before? What two did we do yesterday and the day before? What two types of regression? Linear and quadratic. Now what's the other possible type? Exponential. So today we're going to be talking about how cancer cells grow and then after medication how they die off. So does anybody have a guess on what type that might be out of the three? Exponential. Because that's the only one we have left, or because you think that's how the actual model will be? Okay, I have a little bit of both. Taylor thinks it's because the only one we have left, so that's good deduction right there. And Eddie said because of how the model would be. Alright, do you remember exponential looks like that, right? Growth. Or decay would look like that. So we're going to see if that's true. How many of y'all, and I know more recently with what's been going on with some classmates, how many of y'all know somebody that has had cancer before? Okay, so we all have been affected by that. I know I have too. So we're going to kind of investigate using the M&Ms how cancer cells grow and then how they die off after medication. All right, and we'll see if you were right by your law of deduction or by what you just think about the model. All right, if you have questions, use your group as a resource first and then use me, of course, if it's a calculator question or a how-to question. But the directions are explained pretty well on the sheet. I tried to make sure that everything was included. Do put your name and your partner's names at the top. There's a blank for all of that. And then you can just get started as soon as you get your sheets. It'll be a little noisy at first because you're going to be shaking the M&Ms in the cup, and that plastic cup makes a little bit of noise, but that's okay. Oh, I do need to tell you why, because you're going to see on the sheet that it says something about the plate, but you have a napkin as well. You see the plate's kind of small, right? So some people started to run out of room this morning on their plate, so they asked for something bigger so you can open up the napkin, spread it out, okay, if you need more space for the M&Ms. And when you're done, just please make sure that you're done with all the work, then you're welcome to eat them.
Tea or down your face?
No, yeah.
Wait, is it empty or is it
Make sure y'all stay in the track. On the program. Make sure you're doing that.
we're going to place 2 M&Ms in a cup or a plate. This is trial number 0. Shake the cup and dump out the M&Ms. For every M&M, add another M&M and then record this.
Lands down by you add
So non-landing block.
but like
You're going to take then what you're putting on the total number of M&Ms you have. Don't put how many.
I was fixing to say Eddie.
Now there's 3.
How many there you go. And then actually you have.
Well, what do we do?
The problem is, yeah.
I was working on it.
For every M&M has the M standing up.
What happened is first, okay, so it's only have 2, that's what happened. Okay, yes, so now we're going to. Now you put those back in, and do it again. That makes sense? And then you'll never go back, and then stay the same. Does that make sense? That makes sense, we all good.
15.
Some people ran out of this before trial 15 trials and we ran out.
I'll do that.
You want to try it?
You can bend up the plate if it makes it easier to pour them back in, or the napkin or whatever. Huh?
I used to get alcohol.
Dump them out. You're supposed to be, that's what the plate and the napkin are for. And if you run out of room on the plate, then you can open up the napkin.
Variables change if you get stuff. 1, 2, 3, 4,
Let's just put it back so we don't get mixed up.
Okay, I had somebody write out on the bill this morning, so that's fine.
127.
34, 36. How many do I have?
Yeah.
132.
Oh no.
I think we have a slower connection.
What are you doing when you come out for?
Yeah, I had somebody write out on 12 this morning.
Oh, one short.
One short. All right, so just put your last, put your last one. Yep. All right, so then you can start your graph. And of course, you can make your own scales so that your data fits. Yeah, it does.
That's already.
Yeah, so that's what, that's kind of the trick.
That's a
I don't know
lot.
how that STEM stuff is, so science and math related there is what. You can spread that napkin out.
Should your graph touch the exact?
Wait, what did you do?
I just deleted it.
You could just do the.
I don't care.
Delete what?
It's why.
You don't have to, don't have to, you don't have to.
Say about
So it's like curve.
We started out with 2, so it would never, the y quadrant just.
I made it worse.
So we only do graph.
Hang on, I don't want to fix it. I don't fix it. I know how it is. Hang on, hang on. That go down to the one that says seven.
Yeah, the y value, you have to watch it.
Oh, you don't have to do that, that's just when you're trying to clear, if you already have something in it. So you don't have to. Welcome. That's why I said that, it can be helpful, it can be confusing if you remember the other stuff.
M&M's that landed green.
Hey, at least it's not.
By looking at your table. Okay, we have one person on the next string.
Is this thing like?
How many
Right, like 131.
We started off with 1 foot short, then 2,
How do you figure that?
and then none. Well, we had 198. No, we added. Yes, so we just do
Don't do.
had 8 left over.
I'm gonna try to take a brief time out for just a second.
Yeah.
Did everybody already answer number 5?
Maybe 250.
Yes.
Okay, what was the answer to number 5?
No.
Why not? Okay, now remember we're talking about cancer cells. You think that's true?
No. It has to start somewhere.
So that kind of is an interesting question. That means that there were never 0 cancer cells, right? Because couldn't it have said start with 0 M&Ms? Okay? And then add 1, I know you have to add 1, yeah. So that's the thing. Could it, does this model, does that mean everybody in the United States or in the world has 2 cancer cells in their body? No, it's like y'all were saying, to do the M&M thing and to see what shows up as an M, you have to start somewhere, right? Yeah, you have to start somewhere. So it doesn't necessarily mean that everybody's walking around with 2 cancer cells, okay?
So, and then baseline, and then
No, I'll do 6 and 7.
Oh,
That's the ones that take so long, so that's all I said.
we don't. Okay, and then we gonna remember that only part.
Nine.
Just,
This one, okay.
Make sure
you
y'all,
can,
Yeah, have
you
that.
can.
and then just count when you're done, right?
We'll also use this as fun to write this.
Second
I
one.
think that's how many you have left. To enter your data. Got it.
And you're only doing this part. Yeah, but I want you to do that. The numbers are wrong, because you created the number 7.
Yeah, fish the.
Oh, you did it, yeah, that's right.
How do you go to your work?
Not right, that's why you're using your mom. Where would you plug the 25 in at? You want to know how many cancer cells you have. So is 25 the answer or is 25 the input? And it's X or Y input.
Yeah.
How do you clear
Oh,
up?
there's it. It's too little for you to see. All right, in the next couple of minutes, you should be starting the next model, the exponential decay. Some of you have already started it, but if you haven't, you should.
For this one, just can we,
Just go to 2 places, the 2 decimal places, yes.
Did you have?
I know, but I wanted to count them, so all we had to do was just subtract it.
That's too much work.
No, but did you have the one
Not
We got
left in.
cash.
where you had to go to the?
There's a lot of them
So
already.
you only do copy of that, so you only do one that has to be.
Alright, there you go.
Or do we even need to do that?
They just need it, a little carrot.
Just subtract the whole and then there's 100 and then subtract that. Okay. I thought I'd let you. I thought I'd let y'all know. But there's 100 and then there's probably.
Times 1.45.
So would that be considered?
Tell me what y'all
It just. Yours does.
1.74.
So you said 2 and not 3, right? Well, that makes perfectly sense.
Yeah.
It's 2 decimal places.
I know I would have to use. Did you get it?
So do we actually need to graph?
You just gotta
Yeah.
Okay.
So y'all want to
Second.
do 15?
You gotta tell it where to get the data, that's what you're doing, so 0 to.
Yeah, exactly.
So do we actually need to graph the regression?
No, you don't have to go back and say that. Just go on those and then go on this. All right, in the next minute, you should be going on to your next model. If somebody in your group's behind, try to get them caught up so y'all can be doing the next one. What kind of regression did you do?
I did it. It's an intro.
You must have done 5. Now hit L1. Okay, there you go. That's good.
Right here. It says second quiz.
Yep, to 2 decimal places.
So.
Now you see,
and then you
I didn't ask this when some people were showing me. Did y'all notice your R on those? If your diagnostics were on, what's your R? You got yours up there, Bob.
0.998.
0.998. How good of a fit is that?
That's not.
Yeah, if you got like a really close to what number?
Oh, wait.
1, then that means that your regression's really good.
I was looking at 50 and
I
like,
see.
why is your number bigger than mine?
Okay, so
Oh, we did not do percentage.
that we created in number 8. rates for dating number of cancer cells that there would be in trial is 25.
Okay, there's
No,
some spaces
it's only
to
doing
where
part
you
two.
can like space
You're
out.
only basically you're just using the equation.
I went like over 2 of
Going on the trial
them.
number there.
Now we have to do this part.
Okay, well, that's cool. You have to do the.
After 88 I get 96.
You know this would be so much easier if we just counted the rest
Just
of
plug it in.
the
Like
days.
this, and then you
And
get
then skip one, and
Just
then
count
the power of 25, and then you get whatever your answer is.
So is that?
So we're still going back.
Remember, some people are farther than others. Some people got done yesterday with the actual experiments, so just finish up answering your questions. And we're gonna stop with a few minutes left so that we can do the part 3, talk about what you found in part 3, which are your compare and contrast.
These have
Okay, well, look back at your data and see if your A's
Let's say 40.
in each equation are close to anything from your data.
I did see you.
Look at that first. Like, look at your A from your equation and see if it's close to any number in your data.
13.
And do the same thing for model 2 and tell me what you find. We're gonna talk about it as a group, I mean, as a whole class, but tell me if you notice anything. Now, it's not gonna be exact, it's just gonna be close.
I really don't know the name.
5, 6.
Part one was the feedback.
When it gets below 4, we're done. We're gonna go
It's a simple question.
because that's what the book says.
Where's the blood?
It should be 6 again. Actually, oh, never mind.
It's 4.
It
is.
No. 3. Yes. Calm down.
So we have to end on trial 5.
I thought they were all turned around.
Hey, whoa.
That's part A.
Okay, the A represents.
Can we spread out the trials?
Can you do what?
Spread out the trials on the graph.
Yeah, I mean, you would just have to count by something different on your X, like half or something like that, to spread them out.
Yeah, let's count by half. This is supposed to start
Draw 6 is 3.
Before.
This part says.
Like we did, like the people that went for like Living Gallagher, because we actually had to go through and like
And
find
16, it says, what are some reasons your
But
results
usually
are
like
different? Because we got
I don't know where it usually goes from, but I know we had to like figure it all out this year.
Okay, but
and then
this
the folders.
equation is based on your
And one of our
data.
things we gave it to
So,
the people
why do you
that all
think
got it.
this gives a different number? How much different was it?
I know I was on one because she said
But the actual
Okay, so,
I made a 114.
notice what this has
Seventh
that you
grade
can't have
and
in
ninth grade.
the
And they all counted 2 of those.
So it's more,
Yeah.
And I made a 140 this year. And
Accurate.
more
It
precise.
doesn't-
might be a good
And
word.
that one man, he would not give me my high scale. He would not give me my B flat scale. And I like played that scale like 10
It's
times.
about A values.
Like, I don't know what was his problem. He must not like he was like
This is song, Presley.
that was his problem.
Have you seen the one where they're on the boat?
Oh my God. I mean, this is the only one I did.
And the girl, it's the one where the
I don't know
girl.
who said it.
Go ahead. I wanted that.
Like, I didn't know what she was asking.
Yeah.
And then Lauren told me, yeah, Lauren told me that, and I was like, I had it right, I was gonna write it down, but I didn't have no space for it.
Good, y'all can eat your M&Ms now.
It's because he
Y'all may already have it, but y'all can eat
the
them.
booster club
Y'all
knows
can
it.
eat your M&Ms.
It's always what the booster club wants. The booster club is
32 per person.
like we're having like a
It really is 32.
I'm
Yeah,
counting.
this one they're doing,
What did y'all say?
first period, and Ally Lowe had their
It was
napkins.
just like Zaxby's said. Like you go to Zaxby's.
Everybody
And
Ally
it's
Lowe.
like they had it at
Eddie, don't touch it. Is that
There's some early 60s channels so usually 32 and a quarter.
All right, y'all, let's wrap it up. So we only have about 8 more minutes so we can talk about this and so we can clean up.
Okay.
So, yes.
And I guarantee you were lost.
All right, everybody put up anything else you're working on, go back to this. On part 3, yeah, anything else you're working on? Anything else you're working on? I know, put that up so we can talk about it.
I assumed that for 1, 2.
Okay, what does part 3, number 1 ask about? The value of A, that's exactly right. Can anybody raise your hand and tell me what you think the value of A has to do with? Raise your hand. Abigail, go ahead. The y-intercept, do y'all agree with that? Is that what everybody put on their paper? Y'all erase what you put, just we won't talk about it. Okay, well I heard you say something else, what'd you say?
I put where the graph starts, like where it begins.
Okay, would that be the y-intercept?
Yeah.
Yeah, why would it be the y-intercept? What trial number is that, Mackenzie?
0.
Trial 0, very good. So trial 0, you go up to whatever you're starting at, so that would be your y-intercept. So, in an exponential equation, what will A always represent? Your y-intercept, all right? It goes on then to ask you about B, correct? All right, did anybody find anything out interesting about B?
One was a fraction or decimal, while the other one was whole.
Okay, now that would that necessarily always be true?
No.
What would that depend on in this situation?
The data.
Your data, right. That's going to depend on your data. Anybody else find out anything interesting about B?
So what is B?
One is bigger than the other one.
Okay,
If
which
the
one was
graph
bigger?
Increases, the one with where the graph went up.
Okay, which is what kind?
Growth.
Growth. Okay, so they're saying that the B on the growth was bigger than the B on the decay. Y'all look and see if that's true. Is that true for everybody? Okay, so can anybody tell me, look a little closer at the numbers, can anybody give me a relationship of those numbers? Yes. Up to 1, to the number 1. Give me a relationship of those numbers to the number 1.
It's not chemistry.
We're not talking about
It means you gotta be looking at your B's.
The growth one is over 1.
Okay, the growth one is what, Justin?
Over 1.
Over 1. Is that true for everybody? And your growth model is your B over 1?
Yes.
Okay, is that true for y'all? All right. What about in the decay model?
Under 1.
Under 1. So you see what a growth and decay model looks like. It's y equals what? What's the equation? Y equals A times B to the x power. What does A represent? Your y-intercept. What does B represent? Whether it's growth or decay. When would it be growth? If B is what? Above 1. When would it be decay? If B is under 1. Now, you don't know this yet. We'll talk about it when we get into chapter 4. But B can never be negative. So that means in order for it to be decay, B would need to be between, it's got to be less than, there you go. B would need to be between 0 and 1. All right? So that's what you should get from all of those equations. That's why I had you do both so you can compare and contrast the differences.
Disclaimer,
All right.
that's what I meant to say. Like by a decimal, like the other one's a whole. Like I meant to say.
Oh, like over, you were thinking over 1. Okay.
Do we turn this?
All right. Yes, if you'll collect them as a group, and then I'll just take 1 stack from each group. You can throw away any napkins or anything like that you still have if you're not using them. And put calculators up here on my desk. And then if y'all would help me straighten up desk today because I do have class coming in.
Told us not to erase it.